All right, let's get going. Anyway, map symbols. You need to learn the map symbols on the VFR chart. You will have the opportunity to look at a lot of those as we do flight planning examples. But just about every written test feedback letter I see, somebody screwed up on the map symbols. So this is a big deal. You need to invest some time into learning the really weird ones. Okay, apparently they expect you to know that. Most of them are fairly easy to interpret, like those large blue blobs or lakes. You know, if you're flying across the ocean, you have like 10 blue maps before you get to Europe. The map legend has a lot of the map symbols on there. We'll look at a few of those. The Canada Flight Supplement actually has a section on the map symbols, so they're there. You need to know more about them than you probably think. That's kind of my point here. When we look at the map symbols, essentially Nav Canada says we break it down into 3 groups, right? We have the topographic information. That's the physical stuff. Lakes, rivers. In some cases, they give you elevations, right? Mountains. The map for British Columbia looks quite different than the map here because they're trying to show you about where all the mountains are and all the high stuff. Cultural information, that's their way of saying, hey, we're going to show you where the cities are. Generally, those are the big yellow blobs. The roads, towers, railway tracks, all of that stuff that's sort of built, right? And then the last is aeronautical information. So it's, airports and radio frequencies and navigation aids and airways and all that kind of thing, airspace especially. And you have to be fairly expert at interpreting that because, you're going to be VFR pilots. So anyway, we'll spend a lot of time with that when we do flight planning. Speaking of flight planning, what you have to learn as new VFR pilots is our pilotage skills. So that means you're going to learn to fly around without using the GPS, without using the VOR, and we pretend that it's 1950 and you're flying around and none of this stuff exists. It's actually not a bad idea because when all that stuff goes dark, and it will at some point, you really just want to not know where you are and not know what to do. Okay, that's the bottom line. So when we take you on a dual or a solo cross country, yeah, we have a GPS in the airplane, but you're not going to use it. You're going to actually do it by reading the map and pointing the airplane in the direction of where you want to go. And you're going to calculate everything out in advance. Even though we have, software and websites that'll do this for you and take away the tedious part, you got to learn the tedious part. Okay, so what you're not going to do on your private pilot flight test is load a flight plan in the GPS and follow the needle. Okay, after you get a private pilot license, we're delighted if you do that. Okay, because it's just a easier way to get around. You're less likely to make an error, but you shouldn't have to rely on it to get someplace. Right? If all of it disappears, you should still be able to get the airplane to where you want to go. And it will disappear at some point. You fly long enough, that stuff will quit. So that's it. So for the private pilot license and the commercial pilot license, we pretend none of this stuff was invented and off you go. All right. Okay. So what I'm doing now is I'm setting you up for next time. Okay. So when we're doing VFR flight planning, some basic questions we have to answer, like what direction am I going to point this airplane? Okay. And that's not as simple an answer as you may think, but we got to look at that. I got to know what heading to fly the airplane. I got to know how long it'll take. Why do I need to know how long it'll take? Give me 2 reasons why I need to know how long this is going to take. Fuel. Okay. Right. Get there before it gets dark. Yeah, maybe. Are you just throwing stuff out now? File a flight plan. He got it first. Okay. He got it first. Yeah, you file a flight plan. You want to get there, before they start looking for you. So that's, a couple of practical things. We got to know how much fuel we're going to need, not just how much we're going to burn, how much we're going to carry, right? So there are fuel requirements. So we don't just take exactly the right amount that we're going to burn. Many pilots have, had an engine failure because they said, "Oh, I got enough gas." Right? And it turns out you don't. And then the other thing we need to be aware of is, what about the terrain? Right? You don't want to hit anything. You don't want to cause any danger to anybody. Now, flying around here, you guys probably have a sense that if you fly at 3,000 or 4,000 feet, you're not going to hit anything. In Western Canada, you're going to hit everything at 3,000 or 4,000 feet. Okay, like that's the truth. So you need to be able to look at the map and make an intelligent decision. How high do I need to go? Right. These are all the sort of the burning questions. So there's a bunch of terminology that you just have to get right. And a lot of this terminology, people don't get it right. So we're going to try and make it so that you have a real understanding. Heading and track are often used interchangeably, and they're not the same thing. Okay? They're not. So when we talk about a track, that's the path over the ground. Right? So if I'm trying to get from here to London, Ontario, if I draw a line on the map, that's my track line. That's the path I'm trying to follow over the ground. Your track can be measured from either true north or magnetic north. We'll talk about that in a little bit. Track in the United States, I tell you this because of your flight calculator, they use the word course. Okay? So anytime you see the word course, it just means track. It means the same thing. It's a path over the ground. Heading is the direction you actually point the airplane. Why wouldn't the heading and the track be the same? Well, the wind, right? If you have wind, it's going to try to push you off track. You have to alter the heading to stay on the track you want. How much you alter the heading, that's what we're going to talk about, how you calculate that. Okay? So track is the path over the ground. Heading is the direction you point the airplane. They're going to be close, but very seldom are they exactly the same. Okay? Unless you have no wind. Ground speed. That's your speed relative to the ground. Well, okay, like, duh, of course it is. Why do we care about ground speed? What gives you the travel time, okay? How fast you get someplace depends on your ground speed. Doesn't matter what your airspeed is. Therefore, when you're flying, you can't think about your travel time in terms of miles. You got to think about it in terms of time, because that's what's going to decide if you're going to run out of gas or not. Right? That's the way it works. So you may do the same trip 100 times. Please don't let it beat up Brantford for a donut. Okay? But you may do the same trip 100 times, and the time to get there may vary a whole bunch, depending on the wind. Airspeed. We have all kinds of different kinds of airspeed. And if you're not really familiar, they all tend to kind of run together. The one that we really need for flight planning is the true airspeed. It's your actual speed through the air. How fast are we really going through the air? That is not what shows up on the airspeed indicator dial, right? That's the indicated airspeed. Remember that your airspeed indicator does not measure airspeed. It's an air pressure gauge. And the higher you go, the greater the difference between your true and indicated airspeed. Every airliner that you guys have ever been on was doing about 500 knots, and it was probably showing 300 or less on the airspeed indicator, because at 35,000 feet, the air is pretty thin. There's not a lot of air coming in the pitot tube. So you're going to use the true airspeed for flight planning, but you're going to need to calculate the indicated airspeed so that you know that things are working properly. Okay? So we're going to have to do that. So very simple math problem, right? If the airplane is doing 100 knots through the air, but I have a 100-knot headwind, I'm going nowhere. I'm basically going to stay over the same point. I will have a ground speed of 0. All right, and there are some days when you just be better off not to go or take the train. The opposite, of course, never exists because tailwinds do not exist. They're only it's a figment of your imagination. Seems like you always have a headwind, especially if the trip is long. But if you think about it, if I have 100 knots true airspeed and I got a 100 knot tailwind, I'm going to do 200 knots. Okay. I once clocked 225 knots in a Piper Warrior over the ground. Okay. It was a really nice tailwind. Unfortunately, it was a short trip, but. So, a little aside, think about this now. When we're talking about the wind, we're talking headwind, tailwind. What direction does the wind usually blow from? Usually from the west. So, you would expect, not as an absolute rule, but for a lot of the, most of the time, if you're flying westbound, you're going to have a headwind. If you're flying eastbound, you're going to have a tailwind. That's the way it's going to be most of the time, except if you have a really long eastbound trip, and that day the wind will be reversed. But that's just Murphy's law, right? But that's kind of what you can expect. Is the the westbound leg is going to take longer than the eastbound leg. That's just what happens. And any of you that fly to Western Canada a lot, you know that. Right? You get the headwind going out to Calgary, you get the tailwind coming back. Right? Go to Europe, it's faster going over than it is coming back generally. So just think about that. And that'll factor into your flight planning as well. All right, simple math. But if I got a 100-mile leg that I got to fly, how long is that going to take if I'm doing 100 knots? An hour, right? Because 100 knots means I fly 100 nautical miles in an hour. Now, practically speaking, we haven't factored in climb and descent and all of that, but you get it. 200 knots, how long is it going to take? Half an hour. These are obvious extreme examples. And normally what you're going to do is calculate something that's some portion of that. Okay. And at 50 knots, 2 hours. Okay. I once flew from Baltimore to Myrtle Beach, and the best ground speed we had the whole time was 61 knots. Okay. I was just determined to get there, but there were cars on the highway passing me, It's like, we had a mechanic that worked here years ago. This guy was old when I started flying, and he swore to the day that he died that when he did his cross country from St. Catharines to Hamilton in a J2 Cub, look it up, for like 35 horsepower, that a kid on a bicycle on Highway 8 passed him. He swore that was true, right? And it could have been, right? He said this kid was passing me, J2 Cub was not the speediest airplane in the world, but a little bit of a headwind, you're not going that fast. And where you can really notice it, occasionally there's a guy that has one of these he has one of these ultralights, but it's a true ultralight. It's like lawn furniture with wings and a chainsaw motor. He's the bravest guy I know. And he'll go up flying, and if there's a headwind, which, like a 10-knot headwind, well, the thing only flies at 20 miles an hour. He's not going anywhere. It's like he's just levitating, making a lot of noise, So it really gives you an illustration of how the wind can affect the airplane. What you're going to learn later, and this is a really good thing to write down, the faster you go, the less the wind affects you. Okay? The faster you go, the less the wind affects you. And by that, we mean it affects you less as a percentage on your ground speed, and it affects you less displacing you off track. Okay? So faster is better when it comes to the variation that's created by the wind versus your true airspeed. Okay, so the next thing we got to talk about is direction. Okay, so we already talked about little bit about the North Pole and the magnetic North Pole and all of that. There's a little more you got to know about that. True north is the actual physical North Pole, right? That's what it is. Magnetic north is where your compass points, and they're not the same place. The angular difference at any point on the surface of the Earth between true and magnetic north is called magnetic variation. That's what it is. Magnetic variation, and it's given in the Canada Flight Supplement. So, as we've already said, magnetic variation is kind of local, and on the map here with an arrow pointing to it is what we call an isogonic line. Okay, and we have them on our chart. An isogonic line is a line on a map that joins points of equal magnetic variation. That's what it is. So anywhere on that 15-degree west line, it's 15 degrees west variation. So that's going to be important for your flight planning. The other one that you want to write on the edges of the pages, again, 3-hour exam knowledge, agonic line. What do you think that is? Zero variation. Yeah, agonic means there's no variation. Somewhere between Thunder Bay and Winnipeg, we have zero variation, right? Thunder Bay is so boring, they don't even have magnetic variation. So 15 degrees west variation means your magnetic compass anywhere along that line is pointing to a place that is 15 degrees to the west of true north. Okay, so that's important for you to understand. The other problem we have with the magnetic North Pole is it moves. It's moving all the time. It's moving at a known rate. Okay, magnetic variation is constantly changing. So we know the variation here is 11 degrees west right now. When I started to learn to fly, it was 6 degrees west. Okay, so it's changed over that time. So it's, it's fairly accurate. The oh, look, they show the agonic line on this map here, so it's where it's zero. Anything to do with direction can be expressed as either true or magnetic. And a big part of your job in flight planning is to keep it all straight. Okay? In other words, don't use true when you mean magnetic or vice versa. You got to keep it all straight. Ultimately, at the end, you want to be able to fly a compass heading, a magnetic heading, and get to where you're going. That's really the end goal. But there's a bunch of steps you have to go through to get there. So we can express any heading, any track, any bearing in terms of true or magnetic. Okay, you just got to make sure you understand what it is you're doing. So all this is showing is westerly variation, the fact that your compass is pointing to the west of true north. Talk a little bit about the relationship of track and heading. And there's a couple of more navigation terms that you just have to get. Otherwise, you're not going to understand the exam question. Okay? So we know that wind has an effect on the path the aircraft follows over the ground. And if you think about it, a headwind or a tailwind is going to affect your ground speed. That's pretty easy, right? If I have a 10-knot headwind, my ground speed is going to be 10 knots less than my true airspeed. Not hard to figure out. But if I had a wind from the side, it would push me off track. Okay? And that's known as drift. So there's the definition of drift. The lateral displacement of the aircraft due to the crosswind component of the wind. That's what it says. Why are we using weasel words like crosswind component? The heck does that mean? So the wind is at an angle. Some of it might be acting as a headwind. Some of it will be acting as a crosswind. The crosswind part is the part that's going to blow you off track, right? And that's what we refer to more correctly as drift. So your goal is to compensate for drift essentially by heading the airplane a little bit into the wind. The problem is, how much is a little bit? And that's what you have a flight computer for. Okay, and that's a lot of what we're going to do is calculate the drift correction, so that at the end of the day, I know what my heading needs to be to keep myself on my track, right? So I'm going to aim the aircraft towards the wind, just like the slide says. Okay. So, hey, look at that. He even put a CX3 up there. Well, that's pretty good. So we can do this on any flight computer. You can do it. You can do it if you have nothing but graph paper. Okay. When I learned to do this, we had a ground school instructor that was in the Luftwaffe during World War II. I guess the Germans didn't believe in flight computers. We had to do this with graph paper. Okay. But, they lost. Take that off the tape. But it's true. Anyhow, the nice thing is that your CX3 does this really, really quickly. And even if you have a CX2, it's pretty quick. The other way we used to do it was with a circular slide rule. Okay. We used to spend hours and hours learning to use that thing. You guys are lucky that you don't need to do this. The other good thing is that, as a practical matter, when you get a pilot's license, there's all kinds of good software programs that'll figure this out for you. So flight planning now can be done very accurately, very, very quickly. Like it takes you virtually no time at all. You do it on your phone, for crying out loud. Like, there's not an excuse not to have accurate numbers, and they're pretty good. So we can solve this on a flight computer. At the end of that calculation, which is sometimes called the wind triangle. Okay. It's a wind triangle because it's based on trigonometry. We're going to know the heading we need to point the airplane correctly so we get to where we're going and counteract the drift. And we're going to know the ground speed. And those are two important things. Which way do I point the airplane? What's my speed over the ground going to be? That's huge. If I know what my ground speed is, how do I figure out the time? What other critical piece of info do I need? What's your distance? And then from that, it's not hard to work it out at all. What I like about the CX3 is it does it all in one fell swoop. The CX2 is very good, but you have to work different menus. Okay. So this is not hard. The unfortunate thing is, because it's not hard, you can put the wrong data in. And put the wrong data in, you're going to get a 100% reliable wrong answer. So you need to have some idea of, hey, what should the answer be? Right? So we need to figure out, to do the wind triangle, I need to know what the true track is. So we'll talk about that. True airspeed, wind direction, wind speed. Those are 4 pieces of info that I need. And your job is to be able to do that. So there's an example. A true track of 90 degrees, true airspeed of 100 knots, wind direction 030 degrees true, wind speed 25 knots. Hold the phone. Where do I get my wind information when I'm flight planning? Where does that come from? Upper wind and something. Upper wind and temperature forecast. Thank you. Yeah. Okay. See, there's always one guy. I knew who it would be. So I would get that information from the winds aloft and temperature forecast. Okay. Not the METAR. Okay. Not the METAR. And hopefully everybody remembers that. Where do we get the true airspeed? You have to calculate it. And how would you calculate it? Pilot Operating Handbook has a chart. That's where you're going to get it. So it's going to be a performance chart, right? True track, you're going to draw a line on the map and measure it. Okay, that's where all this stuff comes from. Nowhere in here are we going to use the METAR. Right? Nowhere. Okay. I want you to pull your CX2 out or CX3, whatever you have. I laugh when people think this is hard, because when we had the E6Bs and those things, that was hard. But before that, we didn't have that. We had graph paper. Drawn this on graph paper. No, doing the wind correction, true airspeed. So you punch in 100, enter. Wind speed, wind direction, track, true course. True course means the same as true track. How could you two guys possibly have a different answer? It's a freaking microchip. The only way is garbage in, garbage out. So your answer should be pretty close to that. That's a CX2 answer. Sometimes the CX3, which supposedly has a better processor, gives a slightly different answer, but that's pretty close. Yeah. Okay. All right. So what does this really mean? It means that I want to maintain a track of 090, basically due east, right? In order to do that with this wind, which is coming from the left and in front of me, I need to fly the airplane at exactly 77.5 degrees. Can you guys fly within half a degree? Yeah. So if you said 78 degrees between friends, that'd be good. But essentially, you're making that course correction to the left. You're pointing the airplane into the wind, and you're going to get a ground speed of 85.1 knots. Right? And the calculator will do all the other calculations using 85.1 knots. If you were doing this using graph paper or a manual computer, you'd never see 0.1 of a knot. Like, you just wouldn't. Okay. So we already addressed this, right? Where did the true airspeed come from? Where did it come from? Pilot Operating Handbook, right? True track, where'd that come from? The line you drew on the map and you measured it with that protractor, right? Wind speed and direction. Wind speed and direction. Yeah, but what are you going to ask them for? Yeah, wind's, aloft, and temperature forecast, not the TAF for like North Bay or something, right? Not going to do that. Okay. So we talked about that. So here's a point about the true track. Okay, this is an important point. To determine the true track, you draw a pencil line on the map. I should qualify that. You can use a pen if you want to. The map's $20. If you want to mark it up and destroy it, you can. But anyway, you draw a line on the map, and for practical purposes, you're going to draw one that's dark enough that you can see it. Right? You're not trying to draw an invisible line here. So you're going to carve yourself out a nice pencil line on the map. You're going to use that square protractor to measure the angle, but you got to measure the angle at the halfway point. Okay? Not at the departure end, not at the arrival end. You got to measure it in the middle. Why? Why do you have to measure it in the middle? Or, if you want to be a navigation nerd, why do you measure it at mid-meridian? Because it's not really a straight line. It's really a great circle. So you're averaging out the effect of the great circle. It will be different at one end than the other. On a short leg, you're not going to notice any difference. You get one with a fair amount of length on it, and you'll notice quite a difference, 3-4 degrees. Okay, so that's important that you do that. When you're measuring your track, and again, you get lots of practice at this in the next couple of lessons, you got to line up the north part of your protractor with the top of the meridian and measure from there. So you get a chance to do that. Wind speed and direction. Don't use the TAF or the METAR. Okay. Use the upper winds and temperature forecasts. I don't know how to drive this home anymore. In the winds aloft and temperature forecast, winds in degrees true or magnetic? Degrees true. Wind speed, knots, kilometers, kilonewtonberries, what? Knots. And temperature when it's given, degrees Celsius, right? Everywhere. Even in the United States where they use Fahrenheit for just about everything, they use Celsius in aviation. Where does the temperature forecast start? What altitude? 6,000. Never given for the 3,000 foot level. So it starts at 6,000. Those are all things you got to know. That has to go in the vault. Okay. That is walking around knowledge. We're not going to do this navigation problem, but this would be typical of, what we'll ask you to do. We'll basically give you the altimeter setting for your performance charts, give you the wind, tell you what percent power to use. This is the kind of problem we're going to start solving on next Tuesday night. And at the end of the day, you're going to solve for true heading, ground speed, and how long will it take us to get there. Okay, and we'll do that. That's the kind of thing you got to be able to do. What I'm going to talk about now is if we consider a scenario where you're a private pilot, you're thinking about going on a cross-country trip, or you get assigned a route for your private pilot flight test. What do you do? What's the order of things? So, we've got a checklist here. We're going to do some of the initial preparation. I'll talk about that in a minute. Select the charts. Might be more than one chart, right? If it's a long trip. For the cross-country flying you do to get a license, it's generally on the Air 5000, but someday we hope you'll go far away. Choose the route. Prepare the chart. So we'll talk about that stuff, right? A lot of the stuff you can do in advance. You don't have to wait until the day you're going. You don't have to wait until the day of your flight test. You can do this stuff in advance. The day you fly, you're going to do things like check the NOTAMs and check the weather. Why don't you do that 3 days before your flight? I can't make this up. We have people do that. Well, I checked the weather 3 days ago. They said it was going to be okay. Yeah, but we're going today. Right? Because things can change. We're going to choose an altitude. We're going to complete the navigation planning form. We're going to file a flight plan. We're going to do all that stuff on the day of the flight. When we're choosing an altitude, what kind of things do you think you need to consider? Wind speed, yeah. The ceiling, how high the clouds are, because generally you don't want to be punching up through the clouds or trying to as a VFR pilot. Cruising altitudes regulation, yep. What's even more important than all that stuff? Yeah, we don't want to hit anything. Okay, we don't want to hit anything. So I'm going to give you a rule of thumb, okay? Generally speaking, unless terrain is a consideration, don't plan to spend more than 1/3 of your time climbing. So that means that you're going to Welland, don't plan to go at 11,000 feet. And don't go to Welland, okay? But if you were going from, you're going from Kelowna to the next town over in the next valley, you're going to have to go to 9,000 feet. Might be a 30-mile flight. Because if you don't, you're going to drill a hole in the top of the mountain. And and so that's the way you want to look at it. So one of the things you're going to do whenever you're flying in an unfamiliar area, you're going to look at the elevation, right? Have some idea that I don't want to hit the top of whatever is out there. I especially don't want to hit it in the middle because it means I goof by a lot. But those are important things to think about. So that's the first thing. Then you're going to consider the cruising altitudes regulation. What is the cruising altitudes regulation? What are we talking about? Who said it? What is it? So you got most of that right, okay? Essentially, if I'm headed eastbound, based on my magnetic track, not my heading, my magnetic track, It's going to be odd thousands plus 500. So what are the odd thousands? Yeah. So I'm going to fly at 1500, 3500, 5500, et cetera, et cetera. Okay. Westbound, I'm going to fly at even thousands plus 500. Why do we do that? So you're not going to hit another VFR airplane because presumably that person's going to be flying at the correct altitude. Why the 500 thing? Why plus 500? The IFR airplanes fly at exact thousands, right? So we don't add the 500. So that's a rule. When does the cruising altitudes regulation kick in? When does it become an absolute law, a rule? Somebody mumbled something that sounded right. Above 3,000 feet, ASL, AGL. Above 3,000 feet AGL, the cruising altitudes regulation becomes a law. Below 3,000 feet AGL, we recognize you may have to pick a weird cruising altitude to meet obstacle clearance and cloud considerations, right? So you might fly around at 1,700 feet or something like that. But once you go above 3,000, even and odd plus 500 based on the magnetic track. Okay. Navigation planning form. There's lots of these out there. We have one that we use in class, and I'm going to give you one of those next week. When do I have to file a flight plan? What's the rule for flight plans? Something about 25 nautical miles, yeah. So here's what the rule says. The rule says you have to file a flight plan for every flight, except if the flight is less than 25 nautical miles from where you started. What about a transborder flight? You're going to Niagara Falls, New York. It's 11 miles away. It's actually the closest airport to us. You got to file a flight plan because you're crossing the border. Even if you're not landing in the United States. So if you take off from here and you fly the south shore of Lake Ontario to land in Kingston, you're flying in American airspace. You have to file a flight plan. Okay, it's required. And the other exception is you don't need a flight plan if you have filed a flight itinerary. What's the difference between a flight plan and a flight itinerary? Yeah, responsible person, right? None of you know any responsible people. So so forget it. Yeah. So a flight itinerary you file with a responsible person. It has all the same information as a flight plan, or is supposed to. A flight plan you file with the FIC, the Flight Information Center. That's how it's done. Who's responsible to close the flight plan? Like, why would you bite at any other answer, right? It is your responsibility. What's the normal time you have to close a flight plan? You got one, that's the default, 1 hour. You can specify a different time. Why would you specify a different time? Why would you say, I don't want you guys to come look for me right away. I'd like you to wait 5 hours. No, then you update the flight plan. If your flight takes longer, you can update your arrival time. It's a good answer. You're flying someplace where it's going to be difficult to communicate. You know, you're flying someplace where maybe there's no cell phone service. Oh my God, some of you guys would die, right? And you may have an hour drive to get to a phone. Not uncommon, even now. Okay, so maybe you plug a little extra time in. What's the disadvantage of making your search and rescue time later? You can do a lot of bleeding in an extra hour, right? You know, that's the cold hard truth. So you want to use that, you know, with some discretion. You know, that's the reality. But anyway, you're going to do that. You're going to file a flight plan. Why aren't you going to file a flight plan? Why aren't you going to file a flight plan tonight for the cross country that you're going to do next Friday? Why not? Things change. Yeah, you file it just before you go. That's the convention. What's the telephone number that you call? It's the one you're going to write down. It's 866-992-7433. 866-992-7433. That is the universal across Canada flight information center, telephone number. Wherever you are, it will ring where it's supposed to. It will ring at the proper flight information center because it knows what area code you're calling from. Okay? That's what you're going to do. Now, with that in mind, I need to tell you we have software that will do this for you. The problem with the software is you can misfile a flight plan really easily. Like we've had people file a flight plan and they didn't really mean to. And the software makes it really hard to cancel the flight plan. So now you got a problem because they think you're going to launch on a VFR flight and you're not. Now what do? Right? You call the flight information center. So here's a bunch of stuff you can do before the glorious day that you launch on your dual or solo cross country or you fly someplace, right? You can do the weight and balance. That way you can disappoint people early and tell them they can't go or they can't bring that steamer trunk full of shoes, right? You can check the CFS. You know, it's maybe a good idea, especially when you're not experienced, to look at it, and any phone calls you need to make, like, do you guys really have gas? That kind of thing. You're going to do that in advance. Make sure you get the charts. So you're going to, if you need a different chart, you're going to obtain it. You can draw the track line and you can draw what we call the drift lines. More about that later. And you can establish your visual checkpoints. So these are going to be places that are going to help you check your ground speed and figure out your real ETA. Because we do a lot of stuff based on forecasts, right? Forecasts are they're a little bit better than lies. Okay? A little bit. There's a little bit of science. There's a lot of witchcraft that goes into a forecast. And it may be wrong. It's not uncommon at all that it's wrong. Okay? And that's something you got to keep in mind. So this stuff all has to be vetted. Okay. So the only two places you need to look for any of this info, your flight training manual, exercise 23, actually has a pretty good section on how to do this. It's pretty simple, and it's someplace that you probably want to take a look. From the ground up is also very strong in terms of navigation. What I would suggest you do, look at from the ground up and then pull the cellophane off that workbook and open it up and do the questions. Okay? Because that's a really good way to prepare yourself. What we're going to do next time is we're going to do actual flight planning practice. So do the calculations, use all of this fantastic technology we have. I'd suggest you bring a pencil, unless you're like unbelievably wealthy and you can just buy a $20 map every time you plan something. But a pencil would be a good idea. Bring all the rest of your stuff. Don't leave any of it in your car or your other bag, right? And just make sure that you got it all, because we're going to use it all.